Very good morning, my dear friends. And in today's video, we are going to learn about the development of the lateral surface of a cone which is cut by a horizontal section plane. That means the section plane is perpendicular to VP, parallel to HP, and it is bisecting the axis of the solid. So there are two steps involved here. First of all, for the given dimension, we have to write down the top and front views of the cone. So whenever the cone is placed on HP, it is seen as a circle in the top view and as a triangle in the front view. So let us write down the top and front views of the cone to the given dimension. Friends, I will mark the XY line. Mark VP and HP indicating first angle projection. Mark the top view of the cone, a circle of the given diameter. And this circle will have a diameter equal to 50 mm specified in the problem. And I am going to divide this circle into 8 equal parts and name this as A, B, C, D, E, F, G and H. O is the apex. And for this base, the front view appears as a triangle. So let us mark this base. From this center of the base, we will take the height that is given as 70 mm. So I will mark this 70 somewhere here. 70 mm is the height of the cone. So this is point A dash and this point is E dash. Friends, we will join this apex to all these points on the base. So O dash to A dash, O dash to E dash, O dash to C and G, I'll call it C dash, G dash. This is H comma B, this to be joined here. This is H dash, comma B dash. This is again similar to that. D and F are here. D dash, comma F dash. So this is D dash, comma F dash. O dash is the apex and O1 dash. There's no place to draw here. So I'll mark it as O1 here. Friends, here the diameter of the circle or the cone is given to be 50 mm and I mark it as 550, 5 indicating the diameter and the height is 70 mm. Friends, here the cone is being cut by a horizontal section plane, that is a section plane which is normal to VP and parallel to HP, bisects the axis. So axis is of 70 mm height. I will mark the midpoint of the axis at a height of 30 mm, 35 mm from the base and draw a line that is the section plane parallel to this base. So I will call it S and S. S is the section plane and this section plane is cutting all the 8 generators of the cone here. So these are the points where the cone is being cut and is asked us to draw the development of the lateral surface of the lower part. This is section plane. We are going to throw away the upper part and retain the bottom part, the lower part. So this is the part for which we are required to draw the development. Friends, you know very well the subtended angle theta for a cone is given by small r by capital R into 360 degrees is the formula to be remembered. Without this formula, you cannot complete this development. What is R? R is the radius of the base. That is, R is equal to D by 2. D is 50 mm by 2 and this works out to 25 millimeter. What is capital R? Friends, capital R is the length of this slant generator or the end generator, O dash E dash, O dash A dash. So friends, this can be obtained after construction of the front view, and this is R. R is the length of the end generator or generator, and this is, remember, is true length because OE is parallel to VP, O dash E dash gives the true length of the generator. So friends, now we have to draw the development of the lower part of the cone. I will call this part as P. Friends, if the cone is not cut by a section plane, then you are going to have a length here that is called R, which is the true length. We'll mark O, and at this point O, we'll mark that angle. Say we have got 120 degrees in that. So this is R again. This angle is 120, calculated from the formula theta is equal to R by R into 360. We will draw an arc here connecting this. So this is the sector angle R. Friends, here let us divide this periphery into 8 equal parts, divide into 2, then again here, divide further into 2 more divisions, and friends, you are divided this 1, 2, 3, 4, 5, 6, 7, 8. The periphery is divided into 8 equal parts. Friends, remember this is the arc of a circle. Friends, after marking the development, assuming it is not cut by section plane, you are going to get the development as a part like this. You are going to get it like that. This is capital R, and this is this curve. This is O. Now friends, none of the generators are totally removed from the section for which you are drawing the development. Hence, you can commence the development from any point of your choice. It could be from A, B, C, whatever it may be. Say I am starting from A. This is B, C, D, E, F, G, H, and finally it is A, because O and OA should be there at the end. If you are commencing from B, it should be OB and OB. Friends, now we have got the development, assuming it is not cut by the section plane. Now we will move back to the front view here and see where all the section plane is cutting the generators. Friends, let us start from O dash A dash. O dash A dash is one of the generators. It is cut here. O dash A dash has its top view OA parallel to VP. Hence, this will also give you the true length. So take this measurement on OA, that is this distance here to here, and mark on OA. This is on OA, again on OA. Remember friends, this the first point over. Similarly, OB and OH are being cut here by the plane, but OB and OH are not true length. You have to shift it to the left or to the right to the true length line and mark on OB and OH. OH and OB. Similarly, OC and OG again cut. All these generators are cut at the same height, and when we produce that to the last line, we are going to get all these points like this. So friends, on all the 8 generators, we have got the points marked because all are being cut at the same height. And friends, I am going to join the points so obtained by a smooth continuous curve. And the portion below this is to be retained. So I will show by a dark line here, the last line below that. And this is, the base of the cone is intact. So friends, show this by a dark curve, the edge dark curve, and here the base by a dark curve. Friends, this is how the development of P appears finally. Friends, that I can show you also by something like this. So when you fold them together, I'll show you. It was like this, friends. It was like this, and it was cut by a horizontal section plane. This is how it appears when it is cut. So you will have a development. If you fold this together, you will get this part. And friends, here the portion of the cone which is below the section plane, and whenever a cone is cut by a horizontal section plane, the so-called that part of the cone is called the frustum of a cone. So in the frustum of a cone, the top and bottom faces, they are parallel to each other. That's why you are getting this curve parallel to this base. Similar to our the frustum of cones, pyramids and all this, you will have that edges parallel to each other. So this is for the frustum of a triangular pyramid. So if you have got a pyramid cut by a horizontal section plane, you are going to get the development like this. Similarly, friends, if this cone is cut by an inclined section plane, the portion of the cone below that section plane is called a truncated cone. So you should know the difference between a truncated cone and a frustum of a cone. So frustum of a cone is obtained when the cone is cut by a horizontal section plane. A truncated cone is obtained when it is cut by an inclined section plane, which is normal to VP. Friends, I hope the presentation was useful and it was interesting. If you like this video, do share, give a liking, and share the information with all your friends. Have a wonderful day.